Hi, this video is on climate change and the water vapor effect. Is it the real cause of global warming? In this video we'll look at water vapor, and we'll show how we're adding 37 times more water vapor into the atmosphere than we are CO2. If you look at the composition of dry atmosphere, nitrogen, oxygen, and argon comprise of over 99.9% of the atmosphere. Carbon dioxide, hydrogen, helium, and a few other gases are actually just trace gases. Water vapor can account for 0 to 4% of the atmosphere. If you look at the Earth from space, about 70% of the Earth's surface is covered with water. The Earth would be about 60 degrees cooler if it did not have an atmosphere. The largest greenhouse gas is water vapor, and accounts for 95% of the warming effect. If you look at the Earth, and the heat that's radiated back into space isn't uniform at all. If you think of the Earth more like a house, the walls of the house would be representative more of the air over the oceans, and that the insulating effect is much stronger, caused by the humidity. The land masses where the humidity can drop to much lower levels would be almost like an open window to a house, and this allows heat to exit. And in the case of the Earth, it allows the heat to be dumped back into space much quicker and much more efficient than over the oceans. With water vapor being such a huge greenhouse gas, I was wondering on Inconvenient Truth, it wasn't even mentioned. So doing some research on Yahoo Green, this is Global Warming Myths and Facts. This is what their thoughts are on it. I'll read this quickly. Myth: water vapor is the most important abundant greenhouse gas. So if we're going to control a greenhouse gas, why don't we control it instead of carbon dioxide? Fact: although water vapor traps more heat than CO2 because of the relationships among CO2, water vapor, and climate, to fight global warming, nations must focus on controlling CO2. Atmospheric levels of CO2 are determined by how much coal, natural gas, and oil we burn, and how many trees we cut down, as well as by natural processes like plant growth. Atmospheric levels of water vapor, on the other hand, cannot be directly controlled by people. Rather, they are determined by temperatures. The warmer the atmosphere, the more water vapor it can hold. As a result, water vapor is part of an amplifying effect. Greenhouse gases like CO2 warm the air, which in turn adds to the stock of water vapor, which in turn traps more heat and accelerates warming. Scientists know this because of satellite measurements documenting a rise in water vapor concentrations as the globe has warmed. The best way to lower temperature and thus reduce water vapor levels is to reduce CO2 emissions. And the parts in red are the part that I'll take exception to, and primarily because of the huge amount of water that man's putting in the atmosphere, primarily through farming. To help show the effect of water vapor in global warming. What in global warming is really the lack of global cooling. So we'll see how how water vapor affects these two cities. I selected two cities, similar latitude and elevation. The similar latitude is important because for any given day of the year, each of these cities would have the same amount of exposure of sunlight, but primarily they'd have the same amount of time at nighttime to radiate heat back into space. And it's at nighttime that I'm really interested, because at night there's no additional solar energy, so you can see what the effect is of the radiation back into space. So anyway, Atlanta, if you look at the high and the low, we get an 18.7 degree drop in temperature. In Phoenix, we get a 29 degree drop. So Phoenix temperature drops much more rapidly at nighttime because it's able to dump much more heat back into space. So you ask yourself, well, why doesn't Atlanta cool as often? It's not because Atlanta has more CO2 in the atmosphere. It's simply because Atlanta has more water vapor in the atmosphere, and that's acting as an insulating blanket. Third city I looked at, Wichita Falls, Texas. If you look at the humidities, it's in between Phoenix's and Atlanta's, and if you look at the temperature drop, it's also in between 24-degree temperature drop versus the 18 and the 29, so it's actually right in the middle of that too. Um, so these temperature drops, if you look at in the ocean, if you look at some towns like Hamilton and the Bermuda Islands, in July there's only 8-degree temperature drop between night and in the morning and low. In Nagasaki, Japan, it's also only 8 degrees. Well, these island uh, locations, obviously the very humid air of the oceans affecting them. So uh, again, the arid regions are very important in helping to help transmit energy back into space. Um, these charts are of the 1980 through 2004, showing an increase in water vapor in the atmosphere. Um, I'll read the bottom. Stratospheric water vapor measurements at a single location, Boulder, Colorado, for the period 1981 to 2000 show a statistically significant increase of approximately 1% per year in altitudes of 15 to 28 kilometers. This is 10 kilometers here up to 28, and you can see this is 1%, 2%, 3%. Below 10 kilometers, you can see the percentage increase is even greater. Um, so the atmosphere, the humidity in the atmosphere has been increasing over the years, and um, I'll say primarily because of effects that we're doing because of farming. Farming methods, although we've been irrigating for thousands of years, that with the world's population growing, much more land mass is now being uh, irrigated and flooded for farming. Uh, this picture's in of a flood farming in the U.S. and then a lot of the U.S. uses these irrigation devices that make this circular pattern uh, of watering. Recreational use of water also uses a lot of water in the areas that they need to keep green. If you look at golf course from space, you can see the stark difference between the irrigated part of the property versus the what would be turning back into desert if we weren't irrigating this property. Here's just a simple test of 2 cups of water that I poured out on the concrete just to see how fast it would evaporate. 6 minutes, most of the water was evaporated. In 11 minutes, all of the water evaporated. And what this is showing, this cup on the right was poured out. This cup on the left is still full to the brim of water. And similar to a farmer's field, a lot of the water that's put on the farmer's field does evaporate very quickly. But if that water were to have been left in that river or stream, most of it would still be in that stream, not being evaporated in the atmosphere. Uh, This is a picture of farms in Colorado. You can see the circular pattern made by the irrigation devices, but really, I mean, these are just huge evaporation fields is what we're really doing. Almost 60% of the world's fresh water withdrawals go to irrigation uses, and unfortunately, most of this water is then evaporated into the atmosphere. This is a chart showing 1950 to 2000. The green is the water use in the United States in billions of gallons, 137 billion gallons a year. So what we're using. The pink line's the population growth. We're now about 300 million people in the United States. Again, the 137, this is billion gallons used in 2000 in the United States. This ends part 1. Be sure to watch part 2, and we'll go into more data and show 37 times more use of, or put 37 times more tons of water into the air than CO2.